Hello everyone, welcome back to our physics session. Today we are deep diving into a fascinating branch of physics called optics. Look at the image on your screen. Every time you gaze into mirror in the morning, fix your hair or see reflection on a calm lake, you are interacting with the law of nature. Today we are going to master exactly how light behaves when it hits different type of surfaces, transitioning from flat plane mirror to curved spherical surfaces. Let's get started. Before we talk about mirrors, let's look at the big picture. What is light? If someone asks you that, what is the proper definition of light? At that time, you can say that the light is a form of energy which enables us to see. Light is not any type of material or object. Light is a just form of energy. Okay, so we can't capture, we can't hostage or kidnap. Okay, we can't kidnap the light. Light make its way. We can stop that light, but we can't put in the jar, because light is a proper form of energy which enables us to see. But light doesn't just do one thing, it exhibits an entire spectrum of phenomena. Okay, as you can see in our mind map, light can polarize, disperse, reflect, refract, diffract, absorb, scatter and interfere. Okay, so in standard 10 CBSE, we just learn about reflection and refraction, but in this video we are just learn about reflection. That's why reflection is today's superhero. When light hits a polished surface, it's bounce back, but it doesn't bounce randomly. It follows the strict discipline of laws of reflection. As you can see in this screen, here is the polished surface. We can say that here is mirror. Okay, this is the incident ray, this is reflected ray. This angle between incident ray and the normal is known as incident angle, angle I, and the angle between normal and the reflected ray is known as reflection angle, angle R. So as I mentioned that reflection is following some strict rule of reflection, law of reflection. The first law says that all lies on the same plane. Here all means incident ray, reflected ray and the normal. As you can see, all lie in the same plane. I'm talking about geometric plane. The incident ray, the normal and the reflected ray all lies on the same plane. The second rule gives the relation between the both angle. I'm talking about the reflection angle and the incident angle. If I just start one laser light which going to touch the mirror at a 30-degree angle to the normal. I'm talking about angle between incident ray and the normal. Then it will bounce off at exactly 30, means 30 degrees. There is no exceptions. So the second law of reflection gives the relation between incident angle and the reflection angle. Okay, so if, as I said, if I just start the laser light from here with making angle of 30° with the normal, so indirectly I told that the angle of incident is equal to 30. That's why, according to the second law of reflection, the reflection angle should be 30°. Okay, the value of incident angle and the reflection angle should be equal. Okay. Okay, so to talk like a physicist, we need to learn the language of optics. When light rays meet or appear to meet after reflection, they form an image. Images have three distinct characteristics. You must memorize that. The first is nature. An image can be real or virtual. A real image is formed when light rays actually intersect at that point, and it can be projected onto a screen like a movie in the theater. Okay, so real image is formed when light rays are really they intersect at the point. Okay, it's actual thing. When we visit the theater and watching movie, at that time the light rays forming the whole picture. Okay, so we can say that the light rays meet at the screen. That's why we can see the clear picture of the that scenario. Okay, so the second is the virtual image, or abhasi in Hindi. We can call abhasi in Hindi language is an optical illusion where rays only appear to meet. Okay, remember that here we are talking about illusion where rays only appear to meet, not actually meet, that only appear to meet. You cannot catch it on a screen as your shadow in the mirror. Okay, second, it's orientation. An image can be erect, meaning it is perfectly upright, or inverted, meaning it is upside down. Okay, the third is size. Compared to the object, an image can be diminished, means smaller, or magnified, means larger. Keep this term in mind because we will use them to describe every single mirror diagram. Let's start with the mirror you use every day, the plane mirror. Okay, when you look at the flat mirror, three things consistently happen. The first thing is the image is always virtual and erect. You don't stand in front of your bathroom mirror. You see yourself upside down, right? The size is exactly the same size as the object, as we can say that h is equals to h dash. Okay, so as I mentioned here, h equals to h dash. When you see in your bathroom mirror or any shiny surface, your height is always equal to your image. Okay, your actual height is equal to the actual height of image. Okay, and the third one is the position is perfect to match. The image is located at the same distance behind the mirror as the object is in front of it. But plane mirrors have very special property called lateral inversion. Your left side appears as the image right side and vice versa. Okay, so as I told that uh, let assume that you are standing in front of mirror at this point. Let's guess it's 1 meter. So your image distance is also 1 meter. Okay, so your image nature is virtual and erect. I can't capture this image onto screen. Okay, that's why we can say that the nature of image is virtual, erect. As we can see that the head of mine is on the upside and the head of image is also upside. That's why we can say that the nature of image is erect also. The size of image is same size as the object. Okay, the size of image is equal to the same of the object size. The position of the image is equal to the same distance behind the mirror, as I already told that. Okay, the distance from mirror to the object is equal to the distance from the image. Here is the special property of the plane mirror. We are talking about the one type of the mirror, that is plane mirror. The plane mirror have one special property, and that is known as lateral inversion. Okay, can anyone tell me why the word ambulance is painted backward on the front of emergency vehicles? Okay, so write it down your answer in the comment box. Exactly, I am telling the answer. It's so that when a driver looks in their rear view plane mirror, okay, that mirror is plane mirror. If we see the ambulance which is coming from the back side of my vehicle, so when I see in the rear mirror, I can spell that, I can see the proper spelling in the proper manner, or we can say the lateral inversion, flip it back and make it instantly readable as ambulance, so they can clear the way. Okay, that's the proper answer of this. Okay, so can anyone tell me why the word ambulance is painted backward on the front of emergency vehicles? If you know the answer, then please write it down in the comment box of this video and send it to us. Okay, the correct answer is it's so that when a driver looks in their rear view mirror, lateral inversion, flip it back. Okay, that's why it instantly readable as ambulance. Okay, so they can clear the hallway. Okay, that's why they painted backward on the front of emergency vehicle in that lateral way. Okay, so as you can see here, okay, that is the reason they write ambulance like that. Okay, now let's step out of the flat world and enter the realm of spherical mirrors. Imagine a hollow glass sphere. If you cut out a slice and paint the outer bulge, as you can see that outer bulge, if you cut the slice and paint the outer bulge, you get a concave mirror that reflecting surface curves inward like the mirror. Okay. And if you just paint the inner side of this slice, okay, and the shiny surface will be here, then you get convex mirror. Okay. The center of that whole sphere, okay, the center of that whole sphere is known as center of curvature. Okay, the radius of that whole sphere is known as radius of curvature, and the half of the radius is known as focal length, and that one point is known as principal focus, where all light rays coming from the infinite distance get passes through through the principal focus after reflection. Okay, so the center of that slice, which is cut from the whole sphere, is known as pole. Okay, the center of this slice is pole. The imaginary line which passes through center of curvature, principal focus, and the pole is known as principal focus. Easy. So everyone, today we covered the foundational concept of reflection, spherical mirrors, and got to know the basic difference between concave and convex mirrors. Make sure you clear up these definitions and terms, because they are the building blocks for what's coming next. In our very next video, we are going to dive into one of the most important and interesting parts of this chapter. It is ray diagrams. We will look at exactly how lights behave when it hits this surface and how different types of images are formed. Trust me, once you understand the rules, drawing ray diagram becomes incredibly easy and fun. Before you jump into the next video, take a few minutes to revise what we learned today. If you found this explanation helpful, don't forget to hit the like button, share this video with your classmates, and subscribe to the channel so you never miss upcoming lectures. Thank you for watching this video. Keep studying, and I will see you all in the next video. Thank you.